Okay, so in any triangle ABC, right, E and D are interior points of AC and BC, respectively. AF, so AF bisects angle CAD, and BF bisects angle CBE, right? And we want to prove that the measure of angle AEB, so this angle here, plus the measure of angle ADB, this angle here, is equal to 2 times the measure of angle AFB, which is this angle here. So let's go ahead and start this proof. So the first thing we want to do is we know that AF bisects angle CAD. So let's go ahead and write that. AF bisects angle CAD, which implies that the measure of angle CAF is equal to the measure of angle FAD. And we'll let both of those equal x. So we know this angle has a measure of x and this angle has a measure of x, okay? Because they're both the same because AF bisects that angle. So we also know that BF bisects angle CBE, right? CBE. So this implies that the measure of angle CBF is equal to the measure of angle FBE. And we know we can let both of those equal y. So this is y, and this has a measure of y as well. Okay, so now let's go ahead and label this angle here w, and this angle here z. So we'll let the measure of angle DAB equal w, and the measure of angle EBA equal z. Okay, so now let's go ahead and take a look at measure of angle AEB. Okay, so by the triangle sum theorem, we know that the measure of angle AEB, right? AEB, which is what we're looking for, AEB, is equal to 180 minus the measure of this angle here, which is 2x plus w, and then minus the measure of this angle here, which is z, because we're looking at this triangle here, right? Triangle EAB. So we know this angle is 180 minus this angle, and we know this is just 180 minus 2x minus w minus z. We're going to do the same thing for this angle here. So that's labeled ADB. So the measure, so by TST again, we know the measure of angle ADB is equal to 180 minus, so 180 minus 2y plus z minus w, which is equal to 180 minus 2y minus z minus w. So they want us to find the sum of this. So let's go ahead and look at the sum. So this implies that the measure of angle AEB plus the measure of angle ADB is equal to, so 180 plus 180 is 360. And then we have minus 2x. So we have negative w plus negative w is negative 2w. And then we have negative 2y, right? And then we have negative z plus negative z is minus 2z. So we have the measure of angle AEB plus the measure of angle ADB is 360 minus 2x minus 2w minus 2y and minus 2z. So now we're going to look at 2 times the measure of angle AFB. So we'll look at 2 times the measure of angle AFB, which is equal to 2 times, so 2 times AFB is going to be 180 minus x plus w minus y plus z, right? So 180 minus x plus w minus y plus z, right? Minus x plus w minus y plus z by the triangle sum theorem. And we know that this is equal to 2 times 180 minus x minus w minus y minus z. And then we can distribute that 2 to get 360 minus 2x minus 2w minus 2y minus 2z, right? And look, measure of angle AEB plus ADB is 360 minus 2x minus 2w minus 2y minus 2z. So we've proven that the sum of these two angles is in fact equal to 2 times the measure of AFB, right? So this implies that the measure of angle AEB plus the measure of angle ADB is equal to 2 times the measure of angle AFB. And that is what we set out to do.